Can I make a full 1-to-1 scale cross-section of the Brooklyn Bridge cable? I have no idea. Let's find out. But first, a trip to the bridge. Brooklyn Bridge, about to do it. I strolled casually over the East River. It was just as cool as I imagined it would be. The iconic arches. The bridge was awesome. And very helpful in my quest were some plaques on the bridge that detailed how the cables were made. It very clearly states on the plaque on the bridge itself that there are 278 wires in every strand. It says very clearly that each wire was 1/8 in diameter. Well, that is easy enough. There are 278 wires in each strand. There are 19 strands in a cable. That's 5,282 wires in one of these cables. That's coincidentally the same number of feet in a mile plus 2 feet. Now you'll never forget how many strands are in the Brooklyn Bridge. Either that or you'll always mess up how many feet are in a mile. How am I going to do this? Easy. To make a 1-foot section, I'll just need to buy 5,282 pieces of steel. That's more than a mile of steel. That's $1,600. Easy. To make a 1-inch cross section of the Brooklyn Bridge, I'll need to buy 5,282 divided by 12 feet of steel. That's 440 feet of steel. Okay, that's still $133. Do you see the problem? Now you and I might find it perfectly reasonable to spend $133 of hard-earned cash to make one of the most interesting pieces of one of the most iconic bridges with some of the most interesting history and landmark engineering. My wife Jennifer, on the other hand, does not. At least, not without a little explanation on why it's so cool. So we're gonna approach this a little differently. 1, I'll tell her how cool it is. 2, I'm going to recheck my constraints. Do I actually need it to be steel just because the actual cable was made of steel and was the first suspension bridge to be made of steel strands? No, I really don't. So I'm gonna do it a cheaper way. I'm gonna do bamboo rods, and guess what? Using bamboo rods, if you need 5,282 of them, it's still more expensive than I should really be putting into this replica. I'm going to bundle 278 dowels together, and then I'll slice them up and get the cross sections of 19 of the strands, put the 19 strands together, and we'll have a cable. Notice the way I'm laying down these strands. These cables were too heavy to be built and then moved across the bridge. Instead, every single wire was a separate trip suspended above the river, about a mile across. It's not surprising that it took 15 months of continual effort to string the 4 cables with a total of 14,361 miles of wire in each of them. As each strand was formed and tied together, it became a mini resting place for the strands above it, and so they were carefully built up in the following sequence. Originally, I was thinking of just showing a cross section sheared clean off, but once I looked at it, I didn't really like the way it looked. I didn't think that the 5,282 individual wires were really popping, so I decided to try to put a little more pop in. Well, it wasn't very long before one of these little clusters exploded and I had dowels spraying everywhere. So I came up with what I thought was a cleverish way of handling it. I took rice, I flipped the dowels in the rice, and then I could sit there and poke out the wires and get a nice 3D dimensional effect while I Mod Podged the back of it to hold the dowels in place. I thought it worked pretty well. I mean, this is way better, right? The cables are the key to this bridge. The entire bridge hangs on 4 of these cables. If one of them goes, you don't have a bridge. It was very important that they be able to carry at least 18,700 short tons to be able to handle thousands of people, trains, vehicles, not to mention extreme wind and weather. In 1884, P.T. Barnum even led a parade of 21 elephants across the bridge, convincing the public that it really was safe. Meanwhile, I was having my own crisis. The total diameter is supposed to be 15 3/4 inches. That's what it says on the plaque on the bridge, and that's what all the other sources I can find say as well. My main goal for this build was to make a 1-to-1 scale model. It's not the scale. It's 12.5 inches instead of 15 3/4 inches. That is a little disappointing. Checking some other sources and looking at a little math, it appears to me that each individual dowel would have been better as a 3/16 of an inch. But that's not all. You'll notice the very precise pattern that I followed as I laid this out, and according to the historical documents, that I took great pains to lay out each strand perfectly and Mod Podge them so that they wouldn't move. Unfortunately, they took those malleable strands of wire and they took this clever little machine and ran it down the length of the wire and squoze the ever-living daylights out of this as they wrapped it with another wire into a cylindrical shape. Bamboo rods that have been Mod Podged do not collapse into perfectly cylindrical shapes. Originally, the bridge's design was supposed to have 150 wires less per cable, or 8 wires less per strand, but there was a problem. You've probably been doing a little math and realized that you don't need 4 steel cables of this size to hold 18,700 short tons. and you'd be right. The engineer John A. Roebling built in a safety factor, making it 6 to 8 times as strong, and it's a good thing he did. Due to political corruption, contract for the steel was awarded not to the Roeblings, but to a man named J. Lloyd Hague. Efforts were made to carefully inspect steel that came from Hague. However, a slippery eel would have a good batch of wire inspected at a supply yard, and then in transit to the bridge, he would swap the load with cheaper, brittle, weak steel, and return the same batch of good wire to the yard to be examined by the unwitting inspector. Well, Hague pocketed this difference in value. Before the deception was discovered, over 8,000 miles of defective wire had already been woven into the 4 main cables. So Roebling added 150 additional strands of wire to each cable and estimated that the safety factor was now only about 4 times as strong as what was needed. The whole political and engineering story of the Brooklyn Bridge is awesome, and if this is at all interesting to you, I highly recommend checking out David McCullough's awesome book on the subject. Did I make it to scale model of the Brooklyn Bridge cable? No, it's only 79% as cool. I mean, as big as the model that I wanted. 2, it doesn't look cylindrical. It's supposed to be cylindrical, but I do like this one to show the phases. I set out to make something cool from this amazing book I read, and I did do that. I also learned a lot more about the process. I dug into the pictures, I read the details, and I tasted just a little bit of the engineering challenges that they faced during the Brooklyn Bridge. I just picked up a 3D printer and I've got some ideas. You might be surprised at just how easy it is to get started modeling and doing your own 3D prints. Here's a link of my experience below.